Alright, so what I want to do here, guys, is just review some of the naming stuff. Okay, because it looks like we're still struggling with a lot of the ionic stuff, not so much with the molecular, okay, but a lot of the ionic kind of little rules, okay? Okay, so for naming an ionic compound, first off, we have to know something's ionic. It has what in it? It has a metal and a non-metal, or two polyatomic ions, or a metal and a polyatomic ion. Okay, the big thing is here, basically, it's got a metal in it. Okay, you're very rarely going to have an ionic compound that doesn't. Okay, so we're looking at a metal and a non-metal. Most important things we need to remember. Okay, the metal's name doesn't get changed. All right, so we just write the metal's name. So let's say it's calcium, and it's not capitalized. Okay. And then we write the non-metal's name. So we're looking, but we write the non-metal, it ends in "ide." Okay? So we change the ending if it's a non-metal. Okay? If it's an element that's a non-metal, we change its ending to "ide." So we could have calcium, let's say chloride. All right? Now, how would I write the formula for calcium chloride? What do I always have to do with ionic compounds when I write the formula? How do I find the right numbers? And I have to write their charges down, and then what do I do with the charges after that? Drop and swap. Okay, and that's kind of one of the things people are struggling with right now. So I write down the symbol for calcium, and then I write down calcium's charge. Calcium is not one of those special metals that has more than one. It just has a charge of 2+. Okay, so there's no confusion there. Calcium, and then I write chlorine, and its charge is -1, and then I drop and swap. So the 1 drops and comes over here, but we don't write 1s, so nothing goes there. Okay, we swap the 2 over and then drop it down, and we've got CaCl2. The reason that we do that is to make sure that there's the same number of positive charges, 2, as there are negative charges. -1 times 2 is -2. The swap and drop just eliminates you having to do that math. Right? So it's kind of handy that way. Now, once in a while, you run into special situations where the metal has more than one possible charge, okay, with ionic compounds. So an example could be this compound here. Let's do it this way. Okay. So I start writing this out the same way I did with calcium chloride. I just write out the name of the metal, copper, okay, and then the name of the non-metal, nitrogen. What's wrong with that? No one stop me. It should be nitride, right? Because the non-metal always ends in "ide." Okay. Now, when I look at my periodic table, I see that copper can be a 1+ or it can be a 2+. Right? So what I got to figure out is, okay, which one is it? Non-metals only ever have one possible charge. So I look at nitrogen's charge, and it's -3. All right. So now I multiply these two numbers together to figure out how many negative charges there are, because every nitrogen is -3, and this compound has 2 of them. That means there's 6 negatives. So there have to be 6 positives. If I want to figure out what the charge on copper is, I divide how many positive charges I need by the number of coppers I have to get them from. So 6 divided by 3 is 2. So this is copper 2 nitride. Okay, that's how we figure out the Roman numerals. Now, the other thing that I saw on the quiz was giving people trouble had to do with going the other way. So you were given a formula that contained Roman numerals. So let's say sulfide. Okay, so I've got iron 3 sulfide, and I saw this a whole bunch. Okay, I saw people just saying, oh, there's 3 of them, because that's what the Roman numeral means. Is that what the Roman numeral means? No. Okay? The Roman numeral tells us use 3 when you drop and swap. So the charge on iron is 3 plus. Right? That's the whole reason we go through all of what we did up here to figure out the Roman numeral. So iron is 3 plus, sulfur is minus 2. All right, so I bring the 3 over and I drop it down. I bring the 2 over and I drop it down, and I'm done. Fe2S3. Okay, that's what the Roman numeral tells you. Use this number to swap and drop. Everybody good with that so far? All right. There's lots of little special rules with ionic compounds, okay? That's what makes them tough. The molecular stuff, it's easy. It's prefixes and names, and that's all there is, okay? But the last thing that we saw was when there's a polyatomic ion involved. And I saw a few people getting confused with what to do with the numbers when they swapped and dropped. So for example, one of the ones we did yesterday was sodium carbonate. Okay, and I saw a lot of people, they started out right, they went, okay, sodium's +1, and they went, all right, then carbonate. All right, and it's -2, and they had a 3 here, and then they went, oh, I can't have a 3 there because when I drop this 1, it needs to go there. Is that what I'm supposed to do? No, carbonate has to stay the way it is. CO3 is carbonate. CO is carbon monoxide, an odorless, colorless gas that is deadly. Okay? Those are two very different things. Right? You can't change the numbers on a polyatomic ion. All you can do is, if you need to, is use brackets and put a number outside of those. Right? In this case, do I need to do that? No, because it's a 1. Right? Then I bring the 2 over and put it here, and I'm good. Okay? So we don't want to change the numbers, Owen, put the phone away, okay, on our polyatomic ions. Okay, another example of that, okay, is when we have to use brackets. So if we have, let's say, magnesium nitrite. Okay, if I have magnesium nitrate, okay, obviously it's the ionic because it's got a metal in it. Magnesium is 2+, nitrite is NO2, and it's got a -1 charge. Right? So now I bring the 1 over here, I'm done with that, and now I bring the 2 over and drop it down. I can't leave it like this because that says there's 1 nitrogen and 22 oxygens. I want it to say there's 2 nitrites. So I put it in brackets. Okay, is that making a little bit more sense? Okay. The other mistake I saw a few times was changing the ending of the polyatomic ions' names. Right? Do we ever change polyatomic ions' names? No, because what happens is, and it happened with nitrate. Okay, I can't remember what metal it was with. Let's just say it was sodium nitrate. Okay, so people were going like this. They had the name sodium. They were given the formula, and it looked like this: NaNO3. And what they were doing was going, oh, well, I got to change that to ide. Well, that's not sodium nitride. This is sodium nitride. Right? Nitride is just nitrogen by itself. That's why we can't change the ending of these names, because it changes it into something else. All right? Does everyone follow me there? Right? Those are the mistakes I saw yesterday. They're not huge mistakes, but I saw them enough times that I think it's worthwhile we review that a little bit and then do some practice ones here, okay, just to kind of make sure we've got it. Because when we come back from the break, we're going to be moving on to chemical reactions. And in order to write chemical reactions, you got to be able to write formulas correctly. You got to be able to write names correctly. Okay? Like I said, the naming is the foundation for everything we're going to do here. All right. With the molecular stuff, okay, the big deal there is know your prefixes. Very rarely do you ever have a prefix greater than 5. Okay, so really you need to know up to 5. I mean, up to 10 is great, but very rarely does it go over that. Okay? All right, I'm going to put about 10 examples up here. I want you guys to do them, then we'll go over them, and then I want you to finish up your naming sheets. Okay? Okay, so if I give you a formula, I want the name. All right, try those 5. Okay, let's have a look at these 5 here. So for our first one here, is this ionic or molecular? It's ionic. Calcium is a metal. Okay, so we've got to name it as such. So we name calcium with no capital letters. Okay, and this stuff here, polyatomic ion, is nitrate. Right, and that's all we have to write. No prefixes. Okay, nothing like that. It's just an ionic compound. All right, our second one, we've got nitrogen and oxygen, both nonmetals, so this is a molecular compound. All right, so we name it as such. The prefix for 2 is di, right? So dinitrogen, and the prefix for 3 is trioxide. Now, thing to remember here, because I did see this the other day on the quiz as well, which is which prefix do we not put on the first one? Mono, but that's the only one. It gets a prefix for every other number except 1. Okay, but I did see a few people who just didn't put a prefix on the first thing, even though it needed one on that particular question. The only prefix that doesn't go on the first thing is mono. Okay, number 3, I've got a polyatomic ion attached to another polyatomic ion, which would make this what kind of a compound? Since they're both ions. Okay, they're both polyatomic ions, but it's an ionic compound. Agreed? All right. Anytime you got polyatomic ions, you have an ionic compound. So we want to name it according to those rules. Do I change the name of polyatomic ions at all? All right. So this is just ammonium carbonate then. Okay. I write down the names as they appear on the chart. Okay. So even though it looks tricky, it's actually one of the easiest ones because all you have to do is look up the 2 names and write them down together. Okay. Now, it is a bit tricky, especially when I use ammonium, because ammonium starts with nitrogen, which is a nonmetal, and sometimes that throws people off. All right. Remember, if you see more than 2 elements in a compound, you have a polyatomic ion, and you're dealing with an ionic compound. Okay. All right. For number 4, I've got nickel and I've got sulfur. So this is going to be nickel and sulfide, but does nickel have more than one possible charge? It does. All right, so I look at sulfide. Sulfide's always a -2, so nickel must be a +2. Right, so this is nickel 2 sulfide. All right, and our last one here, I've got silicon and oxygen, ionic or molecular? Molecular, okay? Silicon is a non-metal, but sometimes it throws people off when I give them something that's a solid, okay? Like silicone or carbon, okay? Phosphorus, things like that that are solids. People sometimes get thrown off that, oh, that seems like it should be a metal. Guys, if it's on the right-hand side of the staircase, it's a non-metal, okay? It might be a solid, but it's not metallic, all right? So silicone, does this need a prefix? No, okay? So silicone dioxide. Okay, is that making sense? Daniel? Yep. Because it's an ionic compound. So I don't need any prefixes, right? I just write the name and the name. All right, so I'm going to put 5 on here that now involve, I'm going to give you the name. You have to write the formulas. Okay. Okay, give you a couple minutes on those. Okay, let's have a look at these ones here, guys. So for number 1, I've got lithium sulfide, which is an ionic compound because lithium is a metal. All right, so I start out by writing out the metal and its charge, +1, and the non-metal and its charge, -2, and then I drop and swap. Okay, so it's Li2S. All right, number 7, little bit trickier. Okay, I picked this one on purpose because I wanted to show you basically all the exceptions that can possibly happen. Okay, lead 4. So that means write lead, and what charge am I using? 4. Okay, +4. And oxide is -2. Now when I swap and drop, I get 2 and 4. Should I leave it like that? No. What should I do with it? Reduce it. Okay? With ionic compounds, you always reduce. Molecular compounds, you don't. Okay? But with ionic compounds, if you can reduce it down, you should. So this actually is going to be PbO2. Okay? Because 2 and 4 reduces down to 1 and 2. All right, number 8, phosphorus trichloride, molecular compound. There's no prefix on phosphorus, so that means there's how many of it? 1. Okay, and trichloride means that there's 3, PCl3. All right, number 9, I've got a metal that has more than one possible charge. Okay, so it's iron, and the Roman numeral tells me to use 3+ when I do the swap and drop, and that's combined with carbonate, which is CO3, and that has a -2 charge. So I bring the 2 down to here, and I bring the 3 down to here, but I can't have two numbers together like that, so I enclose it in brackets. Okay, is this making sense, guys? And then our last one, we have a molecular compound, dicarbon hexahydride. So di means 2, hexa means 6. Do I reduce that one? No, it's molecular. Okay, I have to leave it that way. All right, questions on any of that? How many people have done all 5 naming worksheets? I kind of thought there weren't too many. Okay, if you are done all of the naming worksheets, then I'll find something else for you to do. For the rest of you, okay, get done the rest of those naming worksheets. Okay, we need that kind of practice so we're ready to do our reaction stuff when we come back from the break. And guys, remember, you're going to need to refer to the keys for those. Okay, so that you can see if you're doing them right. How many should you do before you check the key? 4 or 5 tops. Okay, so go to my website. Okay, under Science 10 stuff. Okay, and you will find, okay, down here in the chemistry folder, near the bottom, way down, okay, all the naming keys. All right, so naming key 1, naming key 2, okay, and I think I put those, I numbered them in the order you got the sheets. Okay, so they should go that way. Just, obviously they look just like your sheet, so you can tell whether you got the right one or not.